So I've previously given you an introduction video on exponentials, talked to you about the fact that they can represent growth and decay of functions and situations. What I'm going to do here, I'm going to set you a couple of questions relating to exponentials, looking at growth and decay. I want you to read the questions, pause the video, have a crack at them, and then come back to the video and check your answers with the working that I'm going to show you later on. So here you go. First one, safe and secure building society calculates the amount in Aisha's account by using the function a of n equals 600 times 1.1 to the n. 3 parts to this one. First, I want to know how much she deposited. Second is what rate of interest were they paying. And the third one, C, is how much would she have in the account after 3 years. Second question was an open can filled with 1,000 millilitres of fluid, evaporates at a rate of 40% per week. The amount of fluid in millilitres after W weeks is given by that formula there, 1000 times 0.6 to the power of W. How much is left in the can after 1 week? And how many weeks will it take for the volume to fall below 100 millilitres? So pause the video, have a crack at these. So, the first one, the Safe and Secure Building Society calculates the amount in Aisha's account using that function. It's looking at interest. So this, because it's interest in an account, is obviously going to be an exponential growth function. Interest adds money on, so we want to look at that. So first one, part A is how much did she deposit? Well, the deposit is your initial amount, so it's initially what you start with. So for your deposit, the number of years is 0. It's what you start with. So in this case, it's A is 0 equals 600 times 1.1 to the power of 0. Now, anything to the power of 0, any number in the world to the power of 0 is 1. So it's 600 times 1. So her deposit was £600. The second part is what rate of interest they were paying. Now, thinking about rates of interest in an account, it's usually given as a percentage. So you're going to get this % interest per year, per annum, on your account. Now, to look at the rate of interest, we look at the second part. Now, we're multiplying by 1.1, so what we've got to do is take this decimal and turn it into a percentage. So if we multiply that by 100, we get that she's got 110% in the account at the end of every year. So now we have to look at that and say, right, so that's adding 10% on, so therefore her rate of interest is 10% per annum, per year. So her interest that she's getting added on is 10% of the amount in the account from the year before. Now part C was how much she would have in the account after 3 years. Well, we know then that for after 3 years, n is equal to 3. So in this case, we have to calculate A of 3, which is 600 times 1.1 to the power of 3. Now make sure you get this the right way round. Make sure your power of 3 is with a 1.1. Common mistake a lot of times is people do 600 times 1.1, get an answer and then raise that answer to the power of 3 using the calculator. Make sure it's the 1.1 that gets the power of 3. Then it's a case of plug that in your calculator and what you get out as an answer is 798.6. Now, make sure you turn this back into this scenario. 798.6 isn't the kind of answer you want in this. How much would she have after 3 years? It's money. So we have to turn 798.6 into money. Therefore, she'll have £798.60. Make sure you put it in the right format. That could cost you simple marks in an exam, and we don't want that to happen. Second question. Open can filled with 1,000 millilitres of fluid evaporates at that rate per week. There's your formula for after W weeks. We want to know how much is left after 1 week and how many it would take for the volume to fall below 100 millilitres. Now this sort of one, evaporating from a scenario, this is obviously an exponential decay function. So this is an exponential decay formula. Now how much is left after 1 week? We know W is the number of weeks, so in this case, W equals 1. We know that we want how much is left after 1 week. So we need to do A of 1. Now A of 1 is equal to 1000 times 0.6 to the power of 1. Anything to the power of 1 is just itself, so 0.6 to the power of 1 is just 0.6. Multiply that by 1000 and we get 600 millilitres is left. So it's 600 millilitres in the can at the end of the first week. Now, a common mistake that a lot of people make at this point is they then assume that's how much comes out each week. It's not. It's 40% of the previous week's amount that comes out. It's not the same amount each week, because if that was the case, by the end of week 3 we'd have nothing left. The can would actually end up being in the negative amount, something that just can't happen. So it's 40% of the previous week's amount. Now the second one is how many weeks will it take for the volume to fall below 100 millilitres. Now this is one of the trial and error type problems that we've covered in class before. We have to find a week, see how much it is, and then use that to build up and build up. So imagine we start at 3 weeks. Alright, so imagine we start in this at 3 weeks, W of equals 3. So we've then got A of 3, and that's what we're after calculating. So it's 1000 times 0.6 to the power of 3. Stick that in your calculator, and we end up getting 216 millilitres. Now, that isn't less than 100, so we take the next week. So we look at week 4. So in this case, W is equal to 4. So we do A of 4 equals 1000 times 0.6 to the power of 4. Plug that in your calculator, and you get 129.6 millilitres. Now that's pretty close to what we want, but it isn't the exact amount. It's got to be below 100 millilitres. Now logic dictates it would be the next year. However, we can't just do that. We have to prove it. So you have to show when it falls below 100 millilitres, not just say, oh, the previous week was nearly there, this week will be there. So in this case, we're looking at week 5, so it's 1000 times 0.6 to the power of 5. Plug that in your calculator, you get 77.76 millilitres. So by this point, it's now below 100 millilitres. We then have to put it back in this scenario and say, therefore, after 5 weeks, the volume is less than 100 millilitres. We have to explain exactly what it means. Make sure you put it back in the scenario of the question. Don't just leave it as a number sitting on a page. We have to show it. Remember, with this sort of thing, it's also key to prove it. As I mentioned, don't just say, oh, it's nearly there this week, it'll be there next week. Might not happen.